So physics students, we're going to continue our exploration of work today, and work is force times distance. So we've studied force quite a bit. We're combining those together. And all of this is in joules, which is energy. So we're talking about energy and how that can do work for us. So the work net, which we'll talk about more in class, is the change in kinetic energy for any situation. Kinetic energy is motion energy, so that's 1/2 mv squared. So we need velocity to have motion energy. If there's no velocity, there's no kinetic energy. And then we have potential energy, which is due to gravity, which is the weight of an object times the height of the object off the ground, because if we let that go, it will fall and then it will convert into kinetic energy. So I'm going to show you 3 examples of this, and hopefully that'll help us as we move forward. All right, so our first example is a simple one. We have a ramp. It's a certain amount of height off the table, and I have a car. And so if I put the car here, it has potential energy because it's off the ground. And if I let go of the car, that potential energy is going to convert into kinetic energy. So I'm going to let go of the car. And we see that it gains velocity as it goes down. And so that's a conversion of potential to kinetic energy, which is work. Now, if I do it again at a lower height, I still can do that, and I can still get a conversion. I just don't get the same amount of conversion to kinetic energy because there was less potential energy that goes in. In the absence of friction, which there of course would be in this case, all of the potential energy would convert to kinetic energy in this case, and we'll kind of play around with whether there is or is not friction. Our second example is using something that has some force and that we can convert that into work. So what I have is a piece of board with a nail in it. I have a hammer. If I make motion with the hammer, I'm having kinetic energy with the hammer, and it's got mass to it, so it's going to do that. And so very simply, I can pound the nail in with the work that I'm doing from the kinetic energy of the hammer into the nail. If you do this enough, you can actually start to feel some heat, which is friction between the nail and the hammer. And that's actually a little bit of lost energy as we're converting from kinetic energy to work, driving that nail into the wood. But again, an example of energy and work. Our third example is going to be another example of potential energy. So I have this box of paper which has a lot of mass, and every point of lifting it up, I gain potential energy, right? And that potential energy can be converted into kinetic energy. So I'm just going to drop the box for a second, and you see there was a lot of energy going. The table went round and round and everything like that, and I didn't even drop it from that big of height. But again, it's the combination of the mass and the height. So now, just to show you that you can actually do productive work with this, if I lift this up above my can, I have potential energy, and I'm going to let go. And you can see that the energy did some work. It crushed the can, which is doing force over a distance on the can from the energy that was in the box based on its mass and its motion. So that's our third example.